Hi, everybody. Today we're going to talk about fractions and understanding division with fractions. And the last couple of days we've been working on multiplying fractions. And if you like what we were doing there, and it was pretty nice, especially compared to all that work we were doing with decimals and multiplying decimals, dividing decimals, this is so much easier. And if you enjoyed multiplying, good news for you. When we divide fractions, we actually can't divide fractions. And you might be thinking, well, what? We can't divide fractions. I guess lesson's over. But actually, what we do is we just change all of our division problems into multiplication mode. And we do this by using something called reciprocals. So I'm going to talk about reciprocals today. And what we want to do is instead of dividing by a fraction, you multiply by the reciprocal of the second fraction. And I'll explain why that works in a little bit here during this lesson. But first of all, let's discuss what reciprocals are. Reciprocals are fractions whose product is 1. And I'm going to put a little asterisk by this. This is really important. I'm going to say this a lot. Fractions whose product is 1. All right. So I promise this will be on the assignment. You will be asked, hey, what are reciprocals? And you need to look for the answer choice that says, well, they are fractions whose product is 1. Ones where you multiply them together, you get 1 for your answer. So let's take a look at an example here. If you have the fraction 2/3, its reciprocal is 3/2. So you might be thinking, oh, you just take the fraction and flip it over. And that's true. That's exactly what you want to do. Flip the fraction over. But let me show you what happens here. I can multiply 2 times 3, which is 6. And I can take 3 times 2 in the denominator. That's also 6. Well, 6/6, all fractions are division problems, and 6 divided by 6 equals 1. So you can see this ends up equaling 1. Now, you can do your simplifying ahead of time, too. When it's written like this, you can look and say, well, I have a 2 here and a 2 here. I can divide them both by 2. So 2 divided by 2 is 1. Same thing here. And I can do that with the 3's here as well. They're both divisible by 3. 3 divided by 3 is 1. This 3 divided by 3 is 1. And then you can see you have 1 times 1, which is 1, over the denominator is 1 times 1, which is 1. And again, that's 1. You get a product of 1. The same thing happens here. We have 5 times 1/5. Now, keep in mind, when you see a whole number, you can write it as a fraction simply by putting it over 1. It means the same thing as 5 when you have 5/1, because again, fractions are division problems, and 5 divided by 1 does equal 5. Okay, once it's written like this, you have 5/1 times 1/5. And again, I can do some simplifying ahead of time. These two 5's are both divisible by 5. 5 divided by 5 is 1. Same thing here. And you can see you end up with 1 times 1, which is 1, over 1 times 1, which is 1. So that equals 1 as well. So you can see when you multiply these reciprocal fractions together, you get a product of 1. So they're fractions whose product is 1. The bigger question is why? Why do we have reciprocals? Well, I like to think of reciprocals as being like the Mr. Clean of fractions. I mean, you can give me any fraction you want. You could say 3/8, and I can say, I'm going to get rid of your 3/8. I'll multiply it by 8/3, and it'll cause the 8's to cancel out, the 3's to cancel out, and we'll get 1 as a result. So just like that, scrubby, 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 I just got rid of your fraction simply by multiplying it by its reciprocal. All right, so we're going to take a look at some examples here. Well, first of all, what is the reciprocal of 2/5? And hopefully you can see it's going to be 5/2. You just flip over the fraction. You can also say 5/2. It means the same thing. 3/8, what is its reciprocal? Well, 8/3. Just flip over the fraction. What's the reciprocal of 1/4? 4/1, which, by the way, is the same thing as 4 as a whole number, because 4 divided by 1 is 4. So now what is the reciprocal of 6? Well, we have to be careful on this one. 6 can be rewritten as 6/1. It's the same thing. So its reciprocal then, when you flip these over, would be 1/6. That's the reciprocal of 6. All right? So when we're dividing by fractions, to divide by a fraction, you multiply by the reciprocal of the second fraction. So in other words, we're going to take the second fraction, the divisor, and we're going to write its reciprocal value and then multiply. So here I have 4 divided by 1/2. Now 4, remember, is the same thing as 4 over 1, okay? But instead of dividing by 1/2, I'm going to take 4 over 1 and multiply by the reciprocal of 1/2, which is 2 over 1. And we end up with 4 times 2, which is 8, over 1 times 1, which is 1. And 8 divided by 1 is 8. We can write 8 for our result here. Okay, notice I did not take the reciprocal of the first fraction, the dividend. I left that alone. We changed from dividing to multiplying, and we find the reciprocal of the second fraction. So let's look at this one here. 3 divided by 1/4. I'll do the same thing. 3 means 3 over 1 when we write it as a fraction. But instead of dividing by 1/4, I'm going to multiply by 4 over 1. We'll take the reciprocal of that second fraction. So 3 over 1 times 4 over 1. 3 times 4 is 12 over 1 times 1, which is 1. So we get an answer of 12. All right. Now, some of you might be looking at this and saying, hey, wait a second. I took 4 and I divided, and I ended up with an answer that was larger than 4. I thought when we divide, things get smaller. And usually that's true. If you take 24, divide that by 4, it equals 6. 6 is smaller than 24. Or 8 divided by 2 equals 4. 4 is smaller than 8. Usually when we divide, things get smaller. So why, when I divide here, is my answer bigger than the number I started with? And so let's talk about that here. And so in that problem, 4 divided by 1/2. If you're dividing by 1/2, you're asking how many times will 1/2 go into 4 whole? So I have 4 whole squares here. This represents 4 whole. And if I want to find how many halves there are in this, I'm going to go ahead and cut each of these squares in half, okay? So I'll cut this one in half here, and this one in half. Ooh, that's bad. And this one in half. Oh, I lost my line tool. We'll cut this one in half, this one in half. Okay? And I'm not too happy with this one right here. I need to move this over a little bit to cut it in half. Does that look a little better? I think that looks a little better. I might have been faster had I just done this freehand, but so it is. So now I've split each of these holes in half, and now if I'm dividing by 1/2, how many halves are there in these 4 whole? Well, I have 1/2 here, 2 halves, 3 halves, 4 halves, 5, 6, 7, 8 halves. So 4 divided by 1/2 is 8. There are 8 halves in 4 whole. Okay, now you could look at this and say, I could have found 8 another way. Since I have 2 halves in each whole, right? 1 whole equals 2 halves. I could take 2 and multiply that by 4. 4 times 2 also gives me 8. So as you can see, dividing by 1/2 and multiplying by 2, the reciprocal of 1/2, give me the same result of 8. Okay? Now let's look at another example. 3 divided by 1/4. So this time I'm seeing how many times 1/4 will go into 3 whole. So I'm going to split each of these whole here. I use circles to show the holes this time, into quarters. All right, so I split them in half each way. I'll do that here too. And here. Okay? And now 3 divided by 1/4. How many times does 1/4 go into 3 whole? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 12 quarters. Okay, there are 12 quarters here. By the way, 12 divided by 4 is 3. We have 12. So how many times does 1/4 go into 3 whole? 12 times. Now, again, you could have looked at this and said, well, I have 4 of them in 1 whole. So why don't I just take the 3 whole times 4 and get 12 that way? And so you can see dividing by 1/4 and multiplying by its reciprocal, 4 over 1, gives you the same result of 12. And that's why instead of dividing by a fraction, you can multiply it by its reciprocal and get the same result. Pretty neat, huh? See, a lot of times we see different ways of doing things in math, and we kind of think, well, that's kind of a neat trick. But it's nice to know why it works as well. Okay, so let's look at some examples. Here, 6 divided by 3/4. Now, 6, I need to write that as a fraction, so I'll do that by putting it over 1. Now, instead of dividing by 3/4, we can multiply by its reciprocal. So I have 6 over 1 times 4/3. Okay, so now before I multiply these together, I need to look to see if I can simplify anything. By the way, you cannot look to simplify anything when it's still a division problem. You have to change it into multiplication mode first, then you can look to simplify. And here I have a 3, here I have a 6. I can divide them both by 3. 3 goes into 3 once, it goes into 6 2 times. And now all I have in the denominator are 1s, which means I'm going to get a whole number answer. 2 times 4 is 8 over 1 times 1, which is 1, and 8 divided by 1 is 8. So 6 divided by 3/4 is 8. Let's try another one. 3/8 divided by 2. Now this time, the 2 is a whole number. Let's make it a fraction by putting it over 1. That's pretty nice. But now it's still a division problem. To solve this, I will multiply by the reciprocal of that second fraction. So we have 3/8 times 1/2. All right, so can I do any simplifying before I multiply these together? Well, you might be thinking, how about the 2 and the 8? The problem with that is those are both in the denominators, and we need one in a numerator, one in a denominator to simplify. And there isn't anything to simplify. I'll just multiply these together. 3 times 1 is 3 over 8 times 2, 16. There it is. It's in simplest terms. That's my answer. 3/8 divided by 2 is 3/16. All right, we'll do one more problem here. It's a word problem. You have 8 cups of bird seed. You use 2/3 of a cup of seed each week. How long will your bird seed last? Well, we have 8 cups. We're only using 2/3 cup a week, so it should last quite a few weeks. It looks like a division problem, though, because we want to know how many times 2/3 will go into 8 cups. So I have 8 divided by 2/3. Now 8, I can write that as a fraction by putting it over 1. Okay, so I have 8 over 1, but instead of dividing by 2/3, we're going to multiply by the reciprocal of 2/3, which is 3/2. Great, now can I do any simplifying now that I have a multiplying problem? Yes, I see a 2 and an 8 here. 2 goes into both of these. 2 divided by 2 is 1. 8 divided by 2 is 4. And now I multiply. 4 times 3, oops, 4 times 3 is 12 over 1 times 1, that's 1. So you can see we have a whole number answer. 12 divided by 1 is 12. So what's my label? It is a word problem. I do need a label. And you might look up here and say, well, I think it's cups. Cups might be the label. But look at the last sentence. That's always where we can look to figure out what we need for a label. How long will your birdseed last? How long is a time question. Cups is not a measurement of time. Cups is a measurement of capacity or volume. So let's take a look. You use 2/3 cup of seed each week. Week would be a measurement of time. So it must be 12 weeks. So I've labeled my answer. That birdseed will last 12 weeks. All right, that's it, everybody. I hope this makes sense, and I will see you later.